Welcome to featurewiz, the new Python library for fast feature selection. This new Python library helps you select the best features in your dataset of any size. As long as you can fit it into pandas, featurewiz can find the best features in it. Now, let's look at how featurewiz works. Featurewiz works by using two methods. Both are new. The first method is known as the Sulof method, and it is named in memory of my mom, Sulochana. Sulof can also mean searching for uncorrelated list of variables. First, Sulof finds all the pairs of highly correlated variables exceeding a certain correlation threshold. Let's say zero point 0.7. It can be in either direction, minus zero point 0.7 or below, or zero point 0.7 plus zero point 0.7 or greater. Second, it finds the MIS score, which is the mutual information score of each variable to the target variable. MIS is a non-parametric scoring method, so it's suitable for all kinds of variables in target. Third, it takes each pair of correlated variables and then it removes the one with the lower MIS score in each correlated pair. That way, you are left with only the highest variable, highest mutual information score variable and its least correlation to the others. I'll show you in a chart in a minute. Once Sulof selects a list of variables that are uncorrelated, then recursive XGBoost kicks in. In this, we take the remaining variables and build a data set, split into train and test. We find the top X features using train by having valid as for early stopping to prevent overfitting. We then take the X set of variables that are the top features, and then we take a smaller set of variables for the next iteration. We do this 5 times, and we combine all selected features and deduplicate them. And that's how featurewiz works. Let's see it in action. Here is an example of the breast cancer data set. Here we have 30 numeric variables, and you can see they're all highly correlated to each other through those lines, and the width of the lines indicate, or the thickness of the lines indicate how correlated they are, typically over 0.7 going all the way up to 1.0, or minus 0.7 going all the way up to minus 1.0. You can see the size of bubbles here. These bubbles indicate the size of the mutual information score. The higher the mutual information score, the greater the size of this bubble. You can see here that this particular variable has the highest mutual information score, area worst, and is connected to 3 variables: radius, perimeter SE, and area SE. Now we go through the ones with the highest first. So the highest one, area, is taken. Then we remove the 3 variables that it is highly correlated to. Area SE, perimeter SE, and radius SE are knocked out from contention. This way, we remove variables. We select one variable that has highest mutual information score, and we remove all variables correlated to it because they no longer have any need for them, because that information that they have is already encapsulated in the variable that we have chosen. As we go through this, we are able to remove the variables that are highly correlated to each other and have very minimal information. Finally, we apply XGBoost. In the remaining variables, we use those variables to build an XGBoost model. We find the top X features, we repeat steps 1 and 2 5 times, and we combine all 5 sets of features and dedupe them. I hope you now understood how featurewiz works, and you can pip install featurewiz and start using it for your own dataset. Thank you.